Good morning, everyone. Welcome to our fourth bioaccumulation monitoring training series. I'm Anna Holder. I will be your what's the thing? The DJ person? I don't know what that's called. Anyway, um, today we're going to be talking about quality assurance and quality control of bioaccumulation monitoring data. Tessa is going to walk us through that. Sarah Ryan and Sherry Norris and I are going to talk about some different pathways of how to how to potentially use bioaccumulation monitoring data once you've got it. And we have Sammy and Lori with us today who are going to talk about tribal data considerations for the California Integrated Report. Next slide, please. So this is just a breakdown of our different sections today, 3 parts, like I just mentioned. We'll have a break about halfway through, and there's lots of time for questions and discussion, so we can be really flexible as we go through. Next slide. We have a couple of Zoom polls today. We have light attendance in person, but that's okay. We still want to hear from you. The polls are just gonna allow us to kind of get a pulse check of where you are with a certain question. I'll launch the poll, give you a minute or so to respond, and then we'll share the results and walk through them together. And I think, yeah, we're gonna get started right away with the poll. So let me start it. The first part, we're talking about bioaccumulation quality assurance project plans. And the poll should be showing up on your screen. We've talked a little bit about QAQC in earlier trainings, but today we want to know your level of experience with developing QAPs for bioaccumulation monitoring specifically. We know we've got a lot of tribal monitoring experts that might have done different types of different types of environmental monitoring, but we're talking about fish tissue or shellfish tissue today. And this is just going to help us guide our discussion in terms of how deep we're going to go. Okay. We've only got a couple of respondents, but we're about 50-50. Some folks have never done a bioaccumulation QAP before, and some folks have written portions, which is great. So we can all, I've even written portions of the bioaccumulation, our statewide program QAP, and I feel like I'm still a novice because I depend on experts like Tessa to help me out. So yeah, I will stop sharing, and I think Tessa, you can take it away.
Hi, everyone. My name is Tessa Foget, and I am in our SWAMP program, surface water ambient monitoring program at the State Water Board, and I am our quality assurance officer for the program. And I've been in this role for about 6 years. And I will say, even though I've been doing this for 6 years, a lot of QAQC still doesn't come like second nature. It's just like things I've learned over time. So I just feel like this topic, often people are like, "Ugh, I don't know what that's all about." But I think you may know more than you realize, and I don't think it's intuitive to anyone. It's like things you learn practically by doing over time. And I guess just mentioning, we did do another session back in February that talked a little bit about writing QAPPs or QAPs, quality assurance project plans, however you want to call it. So that has some similar information about data quality, and also talked about data management. So this slide just kind of shows kind of an overall process of how we work at the water boards. in terms of sort of our cycle where we do monitoring, water, tissue, etc. We assess that monitoring data, and then we may build that into our basin plans and other sort of regulations. Um, and then, we implement those plans to hopefully improve water quality and, meet our water quality objectives. And then we see how we did. We adjust the plans as needed, and it keeps going around. So what we're talking about today here is our statewide and regional monitoring programs and just monitoring in general, specifically fish and shellfish tissue. Anna, did you have anything else to add on that one, or?
Yeah, in part two, we'll be talking about more examples of pathways that we go around this graphic. So we'll come back to this.
Okay, so just starting out with some sort of basic definitions. I think some of us hear the terms QAQC, but so just kind of showing that quality assurance and quality control, they're two parts of a overall quality management system or quality system. The quality assurance piece is really like the planning and systems you have in place that will ensure quality requirements will be fulfilled. So activities that give you confidence that things are going to go as you want them. So some of this is really basic stuff like training your staff, having your QAP approved by all the parties that may participate in the study. So everybody should know that they're, on the same page. Something like choosing a lab that has ELAP or some other accreditation. So, that lab has sort of already been vetted. So it's kind of like relying on these existing systems or building these systems that should get you the quality you're wanting to achieve. And then quality control, it's like how those quality requirements are actually fulfilled. So techniques and activities that fulfill those requirements. It's a lot of, it's the same words written in different orders, but I think the examples are helpful. So, when you go out in the field, do you calibrate your probe before you take your, DO, temperature, et cetera, measurements? And then, like, do you run a blank, if you're doing a lab analysis to check for contamination in the system? So it's like those actual activities you do that like confirm like, okay, the blank has nothing detected. I know there's no contamination here. So they're kind of quality control and quality assurance activities. They can have some overlap, so it's not super clear cut, but generally it's like this graphic shows you have the overall system. Quality assurance is, a lot of that planning and putting those systems in place. And then the quality control is like those specific activities that confirm your quality is there. So this graphic I'm going to use for a couple slides here. It's from a document that we have in SWAMP called QAP's Made Easy workbook. And this is like a basic project management life cycle. There's a lot of different versions with, similar terms, but these are just the ones I'm going to use today. So we kind of start with systematic planning, and then helps us develop our quality assurance plan. Then once we have our plan, we implement the study, and then we do data quality assessment to use our data. And I'm sorry if there's some background noise. I have unexpected construction crew here today. Hopefully it's worse for me than for you. But so in the systematic planning, you're developing your plan. So what do you want to study? What questions are you trying to answer? So it's kind of just thinking through what you're trying to do. And then thinking about, how will you ensure the quality of the data you collect? So you want to think through how you want to use the data to decide how you're going to collect the data so that it is the right quality or right type of data for what you need to, the question you're trying to answer. So then you can, once you figure that out, you can make the plan of how you can collect that type of data and, the quality you need. So, a big part of that is using, standardized procedures and methods for sample collection and sample analysis so that you're kind of building, that's the quality assurance. You're doing standardized practices that can be repeated and reproduced over time. You know what to expect. So next step, once you kind of figured out what you're doing, you're going to document your plan. So that's writing your QAP or your quality assurance plan. So your goal is to document your monitoring design elements that you already, figured out and thought about, and then any procedures that your team members will follow. So, it's just kind of writing everything down. So you can figure out the overall study, other people can learn what you did. Maybe someone who's looking at that data 5-10 years from now can be like, how did they collect this? And it's documented there. So it'll be a project-specific plan designed to provide the type and quality of data required to answer the questions posed by your project. And at least with our current EPA guidance, their QAPs can cover up to a 3-year period, but not all studies are 3 years long. It might be shorter. If it's longer, then they want you to review it again. So your next step, implement your study. First, you're going to train your team, make sure they know what the plan is, and then you're going to go out and follow that plan. So training staff on your SOPs, your standard operating procedures, is really important. Having a kickoff or initial coordination meeting can be really helpful so that your field crews and lab people are coordinated. The lab knows when to expect a sample. The field crew make sure they bring the sample in the correct container and the correct temperature, and et cetera. So this is, following the plan, you're going out and doing your field sample collection, you're filling out field data sheets, taking your observations and records out in the field, bringing your sample to a lab potentially, depending on what you're looking at, and then possibly doing your data entry to get that data into an electronic system like a database like WQX or whatever system you may have. And then finally, you're going to evaluate the results. So review your implementation and results. So did your results meet your data quality objectives? Then, do the data support your goals of your project? Can you actually answer some of your study questions? Hopefully those are yes. But if not, then you bring that in as, what can you learn to improve for next time or change for next time, if there is a next time. So I'm just going to go into a little more detail on each of those steps. That was sort of like the high level overview. So in our QAPs Made Easy workbook that we have a link to in here, this systematic planning, we call it this is the EPA term of data quality objectives. So it's kind of can be broken down into these 6 main questions of what is your project going to study? How are the data going to be used? What data and information are needed? What are the limits of the study? How will decisions be made? And how much error is acceptable? I think some of those questions can seem much easier to answer than others. Usually people don't have trouble with number 1, what are you going to study? You must have had an idea. Whereas the things on how much error is acceptable, I think can feel a little more esoteric or something. What does that mean? And so that's the part we'll get into the quality control where we can show these sort of acceptance limits on your data in terms of confidence limits and things like that, help sort of define that. those questions, those answers to those questions. So a little more on the systematic planning. So we kind of mentioned this already, but so your quality assurance systems are these like systems to ensure quality requirements will be fulfilled. So things like standardized procedures, like for your sample collection, you should have an SOP. Making sure you calibrate your probes at a set frequency. So that's like a thing of how much error. So for like, I don't know, conductivity, or pH drifts a lot. So usually they recommend calibrating that, daily, whereas some things you may only need to calibrate weekly. But so that's sort of like how much error are you willing to accept? If you don't calibrate your pH daily, then it may not be an accurate reflection of the pH of your water. Um, you may have a standardized procedure for data entry. So that could mean, in part, like having a standard field sheet where you record certain observations and information out in the field. And then also like if you transfer, handwritten data sheets into an electronic format, you may have a procedure for that like someone reviews it or something like that. And also just making sure people are trained, and you may document that who's been trained on what date. So, just having that documentation can it builds it. This is the system that you're building. So who's been trained, who's and who did the training and things like that. And then in terms of laboratory quality assurance, like laboratory accreditation, there's ELAP. I will say that for fish tissue specifically, ELAP doesn't accredit for those analyses, and there are other lab accreditations that may apply if you're really looking at tissue analysis. But for any like water or sediment analyses, you would want an ELAP accreditation for a lab. But um, the lab should have standardized procedures for all their analytical methods that they run. So these things you may not be in control of, but you can ask a lab, like you can ask them to share their SOPs or just like confirm what their SOPs are. But if they have a lab accreditation, they've already been checked for that. So that's sort of the nice thing about that. But then you would also want to tell your lab if you want certain quality control samples run during analysis, and how big of batches of samples you would want them to run. And then you can put those things and more in your contract requirements if you get a contract with the lab. Okay, so then moving on to quality assurance plan step. This is similar to the previous presentation in February, but basically the plan can be simple and straightforward. A lot of people, I think, get overwhelmed thinking about QAPs because they feel like, oh, this is like a 100-page document of just gibberish. But it really should be specific to your project. It should make sense to you. The size and complexity of the project should be reflected in your plan. So if it's a smaller project, it should be a shorter, simpler plan. Whereas if it's a bigger, longer, maybe 3-year project, it's going to be longer and more complex to cover all of that. And I really encourage people to, when they're working on a document like this, like think of yourself in the future you. What details are you going to want documented if you're looking back at this study in a few years? Or if you leave and a colleague is looking at it, what would be helpful to them? Okay, so just now getting more into specifics like quality assurance for field procedures. So this would include field crew training so that people are collecting samples or even like taking probe measurements consistently, because that can have a significant effect on your data. And then make, just your planning and preparation for field sampling. So gathering all your field supplies, making sure people aren't missing anything, cleaning and decontamination of field supplies, use of consistent supplies. So like if you're using filters, you don't want to be switching brands, every 2 weeks. So I guess I'm just trying to help you all understand quality assurance is like probably a lot of basic things you may already be doing that maybe you didn't realize or weren't calling that. So let's see, I think I already said some of these things. So, and then like I mentioned earlier, standardized field data sheets. So for recording things in the field, having some sort of guidance on if you're going to do transfer handwritten to electronic later, and then having secondary review of field data entry. So if you have your handwritten field sheet and then you enter that into computer, having a different person look at it and see if there's any typos, basically. And then when we start thinking about quality assurance for lab analyses, labs luckily we kind of have this accreditation system, which is basically evaluating their quality management system. So this should sort of be built in if you're using like an accredited lab. But I know some folks, you may have your own lab on site that isn't necessarily accredited, but you may have a quality management system at that lab. So having a lab quality manual, which is kind of basically documenting all the quality systems the lab would have in place, like training, SOPs, like all the things we already talked about that they would do in a lab to make sure things are going as expected. So accreditation, we mentioned that there's ELAP, there's also other ones that may actually be more relevant for tissue analyses. And accreditation for like lab accreditation, it's for a specific method and analyte combination. So just because a lab says like, we're ELAP accredited, they may only be ELAP accredited to run bacteria or to run mercury, but they may not be accredited in both of those things. So looking at the specific method and analyte that you're interested in and making sure the lab has accreditation in that specific thing. And then if you're going to have a contract with the lab, you can put a lot in that contract to make sure you're getting the quality that you want. So if you're going to have a QAP, a lab representative should sign your QAP if they're participating in the project. And then you can require certain quality control samples are run with each batch, and you can specify the batch size. Typically, I think most labs do, for most analyses, it's 20 environmental samples per batch. And so then, whatever quality control samples would be per that amount. But it does depend, like bacteria, the batches are smaller. So there are quality control requirements in a given method, but you may have additional ones that you want run. If you put that in your QAP and the lab signs your QAP and it's in your contract, then they should be running those. So that's definitely what we do in Swamp. We have additional quality control requirements that are not that are above and beyond what's in a given method. And so we require those in our contract. Um, basic things like they need to meet all the holding times. You can put turnaround times, like how fast you want your data returned to you after they analyze it. And then in your contract, you can also specify your data delivery format in terms of getting a lab report, if you want it electronic, spreadsheet format, and what they report. So you can require that they report both the method detection limit and reporting limit, because that's not standard from every lab all the time. And actually reporting all the quality control results if you're interested in that. So those are just things you can put in place to build your quality system with your lab. And so this is kind of saying the same thing in a different way, but like, how do you ensure and assess the quality of your lab data? So first, use a lab with a quality management system that meets your needs. So typically the best, easiest way to decide that is if it's accredited. Um, so I think most people have heard of ELAP. There's also NELAP, which is like a national ELAP. ELAP is specific to California, and ELAP is like the national. And then there's also ISO. And they, I do know, accredit for tissue analyses. So some of the labs we use for tissue have a ISO accreditation. So that might be something to look for if you are doing fish or shellfish. Um, Make sure you discuss the quality requirements with the lab before you submit your samples. And, you should be able to have communication with the lab and ask questions and make sure they know what your project is about and what you're doing. Um, and then, including quality control samples, that's a way to assess the quality of the data. So there's various data quality indicators, and you can that quality control samples allow you to evaluate. And we'll get into that more next here. Should I pause for questions? I'm not looking at the chat, but should we just,
Sure. We
okay.
we have one. And Sarah, do you want to elevate the one that you added to the chat?
Oh, sure. I actually have two questions.
Great.
Um, yeah, so the first was I've come across this a bunch in the last year and a half. Just was curious about it in case anyone here had an answer. I remember hearing that microcystin analysis did not have accreditation yet. So that's one of the reasons why it's difficult to, there's several methods that are being used through LCM, SMS, and also ELISA.
Yeah.
Yeah, because we've got the equipment to do microsystem analysis, and we're starting to work on certification.
Hmm.
And yeah, just kind of curious. There are some things that labs will analyze for that they don't necessarily have accreditation for, or there's not even
Yes.
accreditation at the state yet.
Exactly. Yes.
Yeah.
So that's a great point, that accreditation is not offered for every single analysis that you may be interested in. Um, yeah, I think you're right that that microcystin is not offered yet, but gosh, I thought they've been working on that for a while. So now I'm like, when are they going to finish that? Um, yeah, I don't
Yeah.
have that off the top of my head, but I have people I can ask and see if there's a status update on that.
I mean, they're using a source method, that obviously, and one that might have been like slightly altered for their particular lab, like they do. But yeah, that's my understanding with it. And the second was, I thought this was really interesting that this isn't a water issue, but it is a lab issue, and that is that earlier this year, the state of California uh, did not allow or made a statement. It was the Bureau of Cannabis Control, I think. And one of the hats I wear over here at Big Valley is I'm their cannabis regulatory agent. So I'm looking at the lab reports for cannabis products all the darn time. And the state of California dropped the accreditation for multiple labs for like THC, being able to analyze appropriately for, correctly, accurately for those analytes or whatever you would call them.
Hmm.
Um, and because I guess they were following up on the accuracy and finding that there were all sorts of issues. So I'm glad to see that the state, does do, I don't know, random checks or requires um, just evaluation, because we really do count on labs to be accurate.
Yeah. Yeah. So that is part of the whole accreditation process, is that annually labs have to do a proficiency test for each of the things they're accredited in or want to be accredited in. Um, Meaning they'll get sent, or they have to pay themselves to buy sort of a random sample of each different thing they want to be accredited in, that will, you know, there's certain companies that make these proficiency tests basically, and they'll say like, okay, you want to be accredited for mercury in water, like we're going to send you this sort of random sample. You don't know what level of mercury is in it. You tell us what you got and we'll tell you if it's, within our like range of accuracy. So yes, they are tested annually on each of the things they're accredited in. That is a hard word to say. um
Thanks.
so that's one of the things that makes you feel good about having ELAP or one of the other accreditations is, they've at least demonstrated like some ability to do that analysis within a certain range of accuracy. Okay. Great segue into sort of our data quality part. So getting more into the quality control. So quality control sample results are indicators for these several things. Precision, accuracy / bias, representativeness, comparability, completeness, and sensitivity. So these are data quality indicators that this has been part of like the US EPA quality system piece for a long time. Some people use this like initial letters acronym PARCS. I don't know if you've heard that term, but it's something some people say. So I'm just going to give a little overview of what each of those is, just as a reminder or refresher. So precision is how close the agreement is between multiple measurements. So can you get that same answer multiple times? Accuracy or bias, the closeness of agreement between a measured value and a true value. So that it's like, if I know that I spiked 5 microgram per liter in this sample and you analyze it, can you get 5 or at least very close to it? Representativeness, so degree to which measurements correctly represent the environmental condition, target organism population, or watershed to be studied. So that's often more in your design of sort of where you're collecting your samples and, how you're collecting them to actually represent what you're interested in. Comparability, so the measure of confidence that one data set can be compared to and combined with another for decisions to be made. So kind of like if you collect data over the years, can you keep looking at that same data with the same view, or like, are you using a totally different method now? And so it's not really comparable. Completeness, comparison between the amount of valid data originally planned to be collected and the actual quantity collected. That one's usually pretty easy. It's like, we wanted to collect 100 samples. We only got 95, but like, hey, that's still pretty good. Sensitivity, lowest value an instrument or method can measure with reasonable statistical certainty. So that's often reflected by like the reporting limit or method detection limit for like an analytical instrument, but it can depend on what type of study you're doing, what that can mean. So just a little graphic illustration for some of these. So this is, if you have low accuracy and low precision, it's like there's only one in the bullseye. Most of them aren't, and they're kind of all over the place. So you're not hitting the same place. So that's low precision, and you're mostly not hitting the bullseye. So that's low accuracy. Whereas this one, you're not in the bullseye at all. So low accuracy, but they're all really close together. So very precise. This one, you've got the high accuracy because they're all pretty close to the bullseye, but low precision because they're, you've got some spread there. And then finally, both high accuracy and high precision. And then I just have this little illustration for sensitivity. So talking about method detection limit versus reporting limit. There's other terms that different groups or people or labs may use. There's like limit of detection, limit of quantitation, the practical quantitation limit, the PQL. We use these in our SWAMP program, but and some of them have more specific definitions, and some of them it's like each program sort of defines in their own specific way. But this is just what I'm going to use today. But if you have questions about other specific terms, we can go into those. So the MDL, method detection limit, is the minimum concentration that can be measured in a matrix and reported with 99% confidence that the analyte concentration is distinguishable from blank results. So this is basically like, you know that you are seeing the analyte, you know you're seeing mercury, for example, and you know it's not just noise like that you would see in a blank, but you don't have the full confidence of what exact concentration it's at. So then that's where we get to the reporting limit, which is the lowest level that can be quantified, where you feel confident in the actual number within the specified limits of precision and accuracy during routine lab operations. And so often the reporting limit, we want that to be like the lowest point on your calibration curve, so that every time the lab is running that calibration curve, which should be for a batch, that they're confirming like, yes, we can see that level. So basically you have your MDL, anything lower than the MDL is going to be reported as not detected. Now I will say, oh, okay. And then in between MDL and RL, we here in Swamp at the water boards, we call it detected, not quantifiable. And we sometimes use DNQ. So it's like, we know that there's mercury or whatever there, but we just have less confidence in the actual concentration. Like there's big error bars on that concentration. And sometimes on a lab report, you'll see that with a J qualifier or J flag, which is an EPA term to mean estimated value. And then anything above your RL, your reporting limit, is like confidently quantified values. Like you feel you have a lot of confidence in that number. And then one thing I just wanted to say is that just because something is non-detect or not detected, that doesn't mean zero, because it really depends on your sensitivity. So if your MDL is, depends on what you're looking at, but if it's like, if your level of interest or concern, your threshold that you're like, if it's above this, we know that's harmful. If your MDL is higher than that, that a non-detect may still actually be harmful. You don't know, it could just be, if your concentration is just below the MDL, but you don't know that, you could still have something there at potentially harmful levels, but just not be able to actually like put a number on that. So for some things, the sensitivity of the measurement of the method is like well below levels of concern. So then, you kind of feel like, okay, if it's non-detect, we're clear here. But for some analyses, are just the way our instruments and methods work, we're not at that level of sensitivity to like be well below what level we know is harmful or to be concerned with. Okay, so now I'm going to introduce another term here, measurement quality objectives. And again, this is like an EPA term that we also use. But so in our SWAMP program, we have measurement quality objective documents. And in those, it includes, for a given set of analyses, what our program requires for quality control samples, the acceptance criteria for those QC sample results. We also have sample handling guidance and recommended corrective actions in our MQO documents. But the part that is actually like what EPA would consider MQO is really these acceptance criteria for the QC sample results. We just sort of like put other useful information in those documents because they are related. So your project or program, can establish measurement quality objectives or these like acceptance criteria in your QAP. And then you would want to make sure to communicate that to the lab prior to submitting samples to make sure. So basically, your acceptance criteria for QC samples can be different than what the lab's like default acceptance criteria are. So you can make that known to the lab that like, I see you have limits, your accuracy can be 50 to 150% of the true value. We want tighter limits for our accuracy, and we want you to flag the data if it's, lower than 70% accuracy recovery. So you can use the lab's acceptance criteria, but then if you ever change labs, you may change acceptance criteria. And so you may just want to be consistent within your program if it's like a long running program, and just you set your own acceptance criteria and communicate that to the lab. So that's what we do in SWAMP. It may not make sense for every single project or study, but just putting that out there. So this is a link to our website on measurement quality objectives, but we have a whole variety of different categories. I'm just highlighting the ones that really focus on tissue. So we have, each MQO document is like 3-4 pages long, and it's mostly just like tables of basic information. So we have one for inorganic chemicals in tissue. So that would cover mercury, methylmercury, selenium, all metals. Then we also have synthetic organic chemicals in tissue, which covers pesticides, PCBs, PFAS, and other organic contaminants. And then we also have a cyanotoxins in water and tissue that covers microcystins, anatoxin A, and nodularin. Those are the ones that's specified for, but I'm not sure if it might be a good starting place even if you're looking at other things. So this is just kind of a different way to think about the same thing of these quality control samples, like what are they telling us? So basically, in each step of your process of collecting and analyzing samples, you want to do some checks to make sure you're not contaminating or sort of that your process isn't causing a problem in your data. So for sample collection, you're going to have some field quality control checks. So you want to check for potential contamination from your equipment or your filter, depending on if you're using those things. And then you also may want to check for precision on your sample collection procedure. So like, how do you check for those things? So you can bring some blank water out into the field and just open the jar and close it. And that's a field blank, just to like see if anything, just you touching it, being out in the air, does that contaminate this, clean water that you brought? And then for precision, you can collect a field duplicate. So you collect one sample and you would collect another, as close as possible, and then see how similar those results are. So then once you collect your sample, you take it to a lab for processing. So again, you want to check for potential contamination in the processing step, and then precision on those preparation steps, which may be like extraction or digestion or filtering, whatever the lab may do to like process or prepare the sample. So that's why you would have a lab blank to make sure that nothing in the lab is contaminating your samples, and then a laboratory duplicate to see, you run 2 of the same thing through the whole system, and do they give you the same results? And then your actual sample analysis, again, you want to check if there's potential contamination from like the instrument, like the analytical system, precision of the analytical system. Basically just check that it's working as expected, giving you the right, the answer you're expecting. And also checking if the matrix, like your sample, whatever is possibly in there, can be affecting the system performance. So these are like the things you're wanting to look for. And so then you have these quality control samples that can sort of give you that information. So I kind of mentioned these already, like these are for field. So you may collect a field duplicate to look for precision of your sample collection procedure. And then you may have like an equipment blank or filter blank, depending on what type of, if you're not filtering anything, you don't need a filter blank, but if you are, then it's helpful to just tell you if there's potentially any contamination in your equipment or filter. Yes, so just kind of saying the same thing in another way. So these tables are, sort of like what you may have in your QAP to show like what quality control samples are you going to collect and what are they showing you. So then when we move on to lab QC, so these are just like all of the possible lab QC samples you might request or require, but it will depend on the actual method of which ones are relevant. You pretty much are always going to have a lab blank to look for system contamination. And then usually you'll have some sort of lab control spike or certified reference material. So that's basically like the lab is putting a known amount of what they know is like a high quality chemical in there. So to check is, are they getting accurate results? So if I know I put 5 microgram per liter in here, is that what answer I get at the end? And then positive control, that's like for the ELISA tests or other biological tests to just make sure your biological reaction is working as expected. Laboratory duplicate, again, that's like anything duplicate is going to be looking for precision. Like, do you get the same answer twice or more times? And then your matrix spike is to show, so you take one of your samples you collected in the field and you add a known amount of chemical to that and see if, the water or tissue or whatever you've collected, is that affecting the accuracy of like what you can extract and analyze out of there. So that will tell you, oh, the tissue really like binds whatever chemical. And so we only got, 70% recovery of what we spiked into that. And then matrix spike duplicate, you get that additional accuracy, but it's really the precision of your matrix. So can you get the same answer twice? And then surrogates and isotope dilution analogs, those are only for organic methods, but they both indicate bias, and it's like adding a different or a labeled version of the chemical into your sample. You don't need to know that unless you're working in an organics lab, but you may see it on your lab report, so just a sense of what it is. So those are just all your QC samples. And then this is just like a piece that I pulled out of our MQO document for inorganics and tissue. So like these are some of the QC samples we require, like if you're analyzing for mercury or any inorganic. So a lab blank, reference material, matrix spike and duplicate, and then a lab duplicate. So in our program, we define an analytical batch as 20 samples or less. So if the lab is analyzing, if they have 30 samples, they have to run a lab blank every 20 samples. So they have to run 2 lab blanks for if they're doing 30 samples for you. So and same for all of those. So that's how we define a batch in our program. That's not how every lab works. So that's definitely the frequency of how many QC samples they run is something to discuss with the lab. And then here we finally get to like these acceptance criteria or the measurement quality objective. So a lab blank, you are looking to see if there's contamination. So you want there to be nothing. You want it to be a non-detect to show that there's no contamination. So our acceptance criteria is less than the reporting limit. Some programs have it as less than the MDL. So that's sort of like a choice you can make. And then all of these that are for accuracy, so the reference material, so that's a lab control, anything that's a spike is telling you about accuracy. And so that's going to be reported as a % recovery. So if I spike 10, but my result is 9, then my % recovery is 90%. And so that would be fine. That's within this recovery range of like 75 to 125. So that's meeting my limits of error. So these are kind of like your defined limits of error that you're willing to accept, and still feel that your data are usable. So, these numbers we've come up with our program based on like many years of experience working with labs and like what's reasonable to expect. Especially in tissue, you do have a more complex matrix than like a water sample. So I guess I'm just saying you don't have to use these same numbers. These are a fine starting place if you don't have other experience or historic data to run on, but maybe you do have experience with the lab and they can get tighter recoveries than that, or maybe not, maybe worse, and maybe wider. So you can adjust that based on the needs of your program and your own experience. Because you see, like for methyl mercury, we actually give a little wider range than for total mercury or other metals. So any spike is going to tell you about accuracy, and that's going to be % recovery. And then any duplicate is going to tell you about precision, and that's reported as a relative % difference, or RPD. And so it's just a little statistical calculation. The lab will do it. And you basically want it to be less than 25% different. So if it's more than that, then it's like you're kind of getting too different and you're like, okay, there's not good precision. There's something going on with these samples or the system. And then we were mentioning cyanotoxins earlier. So this is just an excerpt of our MQO document for cyanotoxins in tissue via ELISA. So these aren't all the quality control samples we require. I just didn't want to overwhelm the page even more. But for example, a matrix spike, it's like per microtiter plate or 20 samples if you're doing it with a different plate. And then here, that's a spike. So that's going to be accuracy and a % recovery. And so here their limits are 50 to 150%. So you can just see that the limits can vary depending on the analyte and what type of thing you're doing. So I'm not going to go into other detail on this because I think we've maybe done enough of that. But so assessing lab QC results, one thing to just check is if you required quality control samples to be run, did they actually report them? Because a lot of labs don't report those as a default setting. You kind of have to tell them you want the QC results. So especially if you told them you required that, or if it's in your contract, just looking at the lab report and saying like, hey, where's the lab blank, or where's the matrix spike data? And then, you can check if you established your own acceptance criteria in your QAP, you can make sure the lab is using those acceptance criteria and not their own. And then if they are sort of like outside of those limits, there should be a flag on them, or like a qualifier. There's different terms for that. So I'm just showing, this is a little excerpt of a lab report. This is just for a water sample because the tissue reports are even more complicated. So I just wanted to keep it simple. But so I'm just kind of showing just if you want to, for every lab, their reports look different. So this may not be what your lab reports look like, but hopefully, you can find some of the same terms on there. So these are like the sample results. So, this is like the name of this sample. But so this was analyzed for like nutrients. So nitrate, nitrite, dissolved organic carbon, ammonia, orthophosphate, phosphorus, TKN, and total nitrogen. So things you might want to look for is we, require that they give us both the MDL and the reporting limit. So both of those are up here. And then I just wanted to point out like this one, the orthophosphate, the result is 0.025, and that is between the MDL and the RL of 0.016 and 0.05. So that has got this J qualifier on it. It's like way over here, real tiny print. But that's what I pointed out earlier on like the MDL and RL. It has this other qualifier too. So it's like you might want to look up in the report what that means. I think this one was a holding time violation because you only have 48 hours to analyze that one. And then I'll just point out here on the total phosphorus, it's a non-detect. So we know that it's less than 0.02, but we can't say anything else. It might be 0.01, but we don't know. So just like those are kind of the sensitivity things that you can look for in your sample results. And, we like that they report, the dilution is important because if the dilution is higher than 1, then that's going to change your MDL and RL. That's going to raise those. It's always good to have the method reported so you know exactly what they're using. Okay, and then in that same lab report, this is a piece of the quality control sample results. So we have here the blank, so that's telling us about contamination. It's a non-detect, love to see that, so that's great. Then this is the lab control spike. So spike is telling us about accuracy, so that it's reported as percent recovery. And so they had 101% recovery for this one, and their acceptance limits are 90 to 110. And so that's right in the middle. That's great. It's, 100% would be perfect. So 101, great. And then this is the lab duplicate. So that's going to tell you about duplicates are always precision. So that's going to be relative percent difference or RPD. So they actually have an RPD of 0 and their limit is 20. So 0 is great. That means they got the exact same number both times. And then matrix spike, that's accuracy again. So a spike. And so that's the percent recovery, 106. Again, that's pretty good. They, for some reason, did 2 matrix spikes. This one was 100, also good. And then they have their matrix spike duplicate. So that one tells you accuracy and precision. So the spike part, they did 100%. And then as a duplicate, they compared that to, this other matrix spike, and they had a 5% difference, and their limit is 20. So, or you want to be less than 20. So this is all meeting our measurement quality objectives. This is a great quality control batch. Like the system is working as we want it to. It's within our limits of error.
Hey, Tessa, before you move forward, can you just walk
Yes.
through the RPD and RPD limit again? Specifically,
Yes.
the limit is the max, and if you're below
Yes.
that, you're good to go.
You're
Is that
good.
right?
Yes. So it's a relative percent difference. I'm sorry, I could have put the little equation up here, but it's not that fun to look at. But basically, it's telling you how different, like you have, a matrix spike and the duplicate. So how different are these answers? I think these are the two that got compared. So the 0.583 and the 0.554. So it's doing a calculation on how different are those numbers, and you want it to be low. You don't want them to be different. So yeah, in this case, the max is 20%, and in this one it's 5%. So you want it to be less than 20%. So 5% is less than 20%. So that's good. Does that help, or any follow-up question? I could try to say it a different way.
Yeah, if that's the max, then that's
Yes,
great.
it's a
So it
max.
doesn't have a range like the the rec does.
Correct. Yeah. The range is like 0 to 20 in this case. Because 0 is the minimum. It could be, if they're exactly the same, the percent difference would be 0.
And then since we're paused, we had a question before about how do you how do you create a lab link? Is it just for tissue specifically? Is it you just add another sample of tissue in a different jar? Like what's happening here? How do we do that?
That's a good question. So for tissue, usually actually people don't use tissue for the blank. They'll use just water, or I've seen, well, okay. I feel like I should have a better answer. I should know this better.
If I'm recalling from our kickoff from this year, when we were talking to the lab, we mentioned like we would put a certain amount mass of tissue in a particular jar, and
yes.
we might need a minimum of 20 grams for a sample. But if we wanted to do other analyses or other things, then in the same jar, we would add more tissue. Is that a thing?
For
Like
the
instead of 20
blank,
grams, we would do like 50 grams so that they can make a decision and stuff.
that would be like for spikes or duplicates, probably
Okay.
for duplicate, but not for a blank. The lab needs to create the blank all by themselves. And I'm sorry, I'm totally like, my brain is like not functioning to think of this right now. I will follow up while the other speakers are going, and I will refresh my brain on exactly how you do the lab blank, create those lab blanks for tissue.
Gold star, whoever
Very,
wrote that
very good
question.
question. Yes. Thank you, Sarah. Okay. I know. That's why I was like, I'll just do a water lab report. That'll be simpler to understand. Okay. I think I just have like 2 more slides. I have not been watching my time at all. How am I doing, Anna?
We're okay.
Okay. Um, okay, so just a little bit about data verification and validation. I don't know if you've heard those terms much. It's kind of a section in the QAP usually. So data verification is usually, well, you usually have at least one level where the lab or whoever is the data producer reviews the data for like accuracy, typos, errors, just kind of does a once over, make sure everything looks reasonable and accurate. Here in Swamp, we do secondary verification. And so that is, someone who was not involved in producing the data, reviews the data set for completeness, and then also, meeting all those our programs, MQOs, or those acceptance criteria, like those ranges or percents. And that they met all of our like sample handling requirements, was it at the right temperature and etc. So then we may add additional flags if something wasn't flagged or qualified as we require in our program. Data validation is similar to that. You have this secondary reviewer, ideally it's someone who didn't produce the data themselves. So it's like another set of eyes, looking at the data for potential bias, appropriate flagging to alert the data user to any potential issues. And it really follows your own program specific requirements. So for example, we have a data validation SOP for our swamp bioaccumulation program that says like, basically what we add specific qualifiers or flags to our data if, let's say, the accuracy was out on, part of this batch, or it's just like program specific to kind of like let our program people know, like, these data look great, they meet all of our requirements. These data had some issues, maybe still use it, or certain flags would be like, definitely don't use it. So the secondary verification and validation can be similar, or like part of the same process, but it's sort of like setting out, you look at the data in terms of, do they meet your program's needs? And maybe you flag it or reject some of the data based on your requirements. So the benefits of that, just looking at your data after, whatever the lab provides, is good, just to make sure the lab is actually providing all the contract services you agreed to. Like, again, like, just if you required quality control samples, did they actually give you those results? And is the lab meeting your acceptance criteria? And if not, you can, ask them to do a corrective action, or maybe if you're not liking the service, you find a different lab. But just, reviewing your data it's like, just because the lab is accredited, you don't necessarily just like take anything they give you and say everything must be perfect. It's sort of like you have to verify that they're actually meeting it consistently. And then just checking the usability of your data for your specific purpose. If you're reviewing as data comes in, you might be able to correct a problem mid-project, because maybe it's something with your field crew of, that something is getting contaminated in the field. So you want to like make sure they're doing their clean and dirty gloves and things like that. Or maybe you'll reject some data because you think it would bias your decision making for whatever you're using that data for. Okay, and then this is just some resources, our web pages, this little workbook to help you like work through your QAP. We have our swamp program plan. We have our bioaccumulation monitoring program, QAP. All of those things, we define all of these terms and have all the equations for things. And, you can just search within the document for like, if you're looking for a certain thing and want a little guidance, or if you want a starting place for your acceptance criteria, the QAP or the measurement quality objective documents are a good starting place for borrowing. Okay, I'm done.
And just perfect. I've said this before, I think during the February training, but if you're trying to write a QAP for bioaccumulation and you see like big chunks of R's that you'd like to reuse and remix, feel free to reach out to me. I will send you a Word version of that baby so you don't have to rewrite things that are already the way you like them. And then we're going to go through questions really quickly, but Sherry Norris from the California Indian Environmental Alliance couldn't stay for the whole time, but she wanted me to point out for folks that SIA has mostly sampled for mercury and methylmercury and have been using Brooks Labs, and I'll add their information that she provided in the chat, and has been working in collaboration with Big Valley Rancheria, and it has been especially useful in sharing fish samples. So one group is sampling or for mercury, and the other is testing for cyanobacteria. And they found that you don't need to think about we found that we do need to think about what our community is eating. So skin on versus skin off, shells on or off. And some fish do hold mercury under the skin and might be higher concentrations of toxins depending on the species and the part of the fish. So the example that Sherry provided is sturgeon used for glue traditionally. And that's all she shared with me. So I don't want to say any more unless, Sarah, if you have more that you want to add to the note that Sherry shared.
Yeah, I think the other thing I would add is that SIA, California Indian Environmental Alliance with Sherry as the executive director, she has set up a few different programs of, if tribes have fish that they want to have analyzed for various contaminants, that they often at SIA have some funding to help pay for that. And then for cyanotoxins, they've been putting into a couple different grants that the tribes can send their water samples over to us at Big Valley, and we'll be processing it and doing microscopy and a few different things. So We're trying to over here at Big Valley, we're trying to be and SIA gave us a freezer, a lab freezer to store any fish that regional tribes are collecting and we can also process them and send them off for analysis if anybody wants. So it's just to know that SIA's been really busy and they're trying to be that focal point and good coordinator if there's any tribes that want to want to take play want either some assistance with funding it, because to be able to use EPA funds to send off to to see what's in your fish, you have to have a quality assurance plan, just as Tessa was saying. um and if you don't, you just want to do a little bit just to kind of get started and take a look. It's quite possible that SIA has a little bit of funding to pay for some analysis, and really sort of to do a pilot. Like obviously the QA is important because you want to make sure you're not contaminating anything and that you're making good decisions with the with your process. But just Sherry and Sia are there to help, and so I just want to point that out.
Awesome.
Thanks.
Thanks. We've been taking questions throughout, but does anyone have any other questions for Tessa before we move to part 2? I'm not seeing anything in the chat. And if something comes up, feel free to add it to the chat. Tessa might be able to respond there directly, or like I know how to find her, so I can send it to her after and add it to the notes and things. Thanks so much, Tessa. You took us like really in nitty-gritty detail that is a lot, I think. It was for me. For the next part, we're gonna kind of step out and think big picture again. And I'm gonna be helped here with Sarah, and I have some notes from Sherry as well that I'll share with y'all. As I was working with our integrated report team, who you'll hear from after the break, I noticed that I keep bringing up this adaptive management cycle, but I didn't really, I haven't really broken it down in a way that I think it could be as helpful as the way I see it in my head. And so, we've been spending the majority of our time here in this monitor phase because this is a training series about bioaccumulation monitoring. Later today, when we hear from our integrated report team, they're going to kind of move us over into the assess phase of how the monitoring data can be used in assessment specific to the water boards. Next, I'm going to kind of walk through some examples of different pathways that data can take and like where it ends up, and we'll touch on a couple of the plan and adjust phases, and you'll see that it's not always cyclical in this order, right? Like sometimes you adjust and then you plan and then you plan and adjust, and that's just like the nature of simplified graphics. And then also wanting to flag in December, we'll hear from OEHA, and they'll walk through their fish consumption advisory process. So that'll take us to like the implementation phase of how data can be used to implement certain things. And specifically, I wanted to walk through different authorities of how different parts of the water boards or our partners, like as government agencies, we're only permitted to do certain parts of this adaptive management process. So for the monitoring phase, we're thinking about the surface water ambient monitoring programs, the bioaccumulation monitoring program. We are only given the authority to monitor, to generate the data. We then pass that on to our surface water quality assessment program, or the integrated report team, where they take that into their process. They don't do any monitoring, they just focus on the assessment. And they don't have any authorities to do any of the regulations or enforcement of their assessment results. Instead, that's passed on to the regional water boards, where they kind of bring that into their basin planning, their training review processes, their TMDLs, and we'll talk about some of those in more specific detail in a second, where they're the one, they don't do the necessarily, sometimes the regional boards do monitoring, but the monitoring or the assessment Instead, they're thinking of taking all of that into their processes and thinking about, how that informs their priorities from a planning perspective, but then also the implementation of, permitting, grants, enforcement, all of that sort of stuff. So again, simplified versions, but it's why working with the water boards can be so complicated, because folks are like, okay, I want to know about, the TMDL process. But you're actually working with different arms of the water board, which is really confusing sometimes. Similarly, each of these different lead agencies and programs have their own, adjust methods, the frequency at which they kind of review their processes and update priorities and things like that. And those are listed on the slide here, and they can range from, annual to like our bioaccumulation monitoring program monitoring plans. We develop one every year. To the integrated report, you'll hear more specifics on their update cycle, but every 2 years is when you get a new integrated report. To the regional boards, triennial review process every 3 years. And then, we've got broader strategic work plans by the State Water Board that happens annually. Our Racial Equity Action Plan is updated about every 3 years, that sort of thing. And for me, I can like think about the processes in my brains, and I just wanted to share my brains with y'all a little bit about how I think about this graphic with a couple of specific pathways for how bioaccumulation data and the integrated report assessments can be used to help us make decisions. We'll talk about, cleanup programs, the tribal beneficial uses designation process, and water quality objective development. Now, those are all in the plan phase, but I'm going to walk you through, all of the phases for that specific pathway. And I'll just want to note, this is idealized pathways, best case scenario. Reality, as we all know, is a little bit more nuanced and complex. So please give me some grace when it comes to how simple I've made this look. The first is bioaccumulation data into TMDLs, or total maximum daily loads. And for the next couple of slides, you'll see a graphic at the top that shows, the different steps of that, this cyclical graphic in a more linear structure. So TMDLs are written restoration plans. They're the plans that the regional board set forth to say, okay, we see these waters are have some issues, and we want to bring it back to our, water quality standards and objectives. And so if we think about the start of the swamp bioaccumulation monitoring data, or all of our swamp data, that gets added to the integrated report process in teal, that is then shared with the regional boards. And they, think about what the assessment's results are during their triennial review process. And based on the priorities they set, they might inform their TMDL programs on, okay, these are your TMDL priorities for the next 3 years. They will do their work at the regional level, and the TMDLs are, designated or designed as basin plan amendments, which is a regulatory process to, get them into gear. And then that is then filtered into permits and compliance and all of the enforcement. And I've added a link here at the bottom to the TMDL webpage, and you can find the links to the TMDL programs for the regions that you're interested in. The second pathway, which I think is one that we've talked a little bit about in past trainings, is the tribal beneficial uses process. Again, this is the idealized pathway. The regional boards are the ones with the authority to update their basin plans with the tribal beneficial use definitions and going through the designation process. A lot of y'all might be in contact with regional board folks and providing feedback and contributing to those processes. And if you aren't and you want to know how, there's a link here to your tribal, to the tribal coordinators list, and that's the person that, or people, depending on how many regions you interact with, you might reach out to. And we'll also flag later, we're going to give a plug for the SIA's Tribe of Beneficial Uses Strategic Caucus, which is a space where tribes can kind of strategize and game plan for that process. But you'll notice that the process is initiated at the regional board during their triennial review process, where the regional board says, this is a priority for us. We're going to focus on TBUs. And then they, through that process, take in the feedback that they're receiving from tribes on, you know, which waters should be designated, which with which tribe beneficial uses. They can also incorporate swamp monitoring data to see like where we've monitored for fish tissue, for example, and what those results were. Additionally, they can kind of take in the integrated report results to say, you know, these water bodies are listed because the tissue levels that swamp shared with integrated report are higher than what we see as safe at the water boards. And so that's an issue that we need to address. And then I think for the majority of the regional boards, we're still at the basin planning phase, where maybe some regional boards have designated or adopted definitions, but we're still figuring out how to designate water bodies with certain definitions. And that is where the TBU Strategic Caucus is coming in, and Sarah and I can talk about a little bit where that is later. The next is bioaccumulation data to water quality objectives. And again, this is like an idealized process where we've got, for example, the tribe beneficial use definitions, but the water quality objectives haven't necessarily been defined yet for those. So we can adopt the definitions, but how do we protect water if we don't have our water quality objectives? And as we develop those and start those conversations collectively as a community, we can, again, incorporate data that you all have or data that SWAMP has, the integrated report assessments, and lots of other things to help figure out like what are our objectives to make sure the water is safe enough to be used for tribal uses and cultural subsistence and all sorts of things. And then just this graphic here on the right, noting that some slight differences in definitions. If you're working with US EPA, they might talk about numeric criteria for your water quality criteria. At the state level in California, we talk about water quality objectives, numeric and narrative objectives. And then the integrated report team can talk more about those things during their spot. That was just super high level, but any questions about those potential pathways or thoughts before I pass it on to Sarah to talk about pathways from a tribal lens? And we didn't talk about this before. I can advance for you, Sarah. Okay, not seeing anything. Great, take it away.
Hey, hey everybody. So I wanted to talk a little bit about Big Valley's cyanotoxin study that they did with fish. We're already, for the last number of years, have been looking at cyanotoxins in the lake, Clear Lake, as well as the creeks. And yeah, we've been monitoring for cyanotoxins in the lake since 2014, and that's because there were these horrendous cyanobacteria blooms that were really worrying people, not just tribal community, but pretty much everybody in general was like, look, it smells terrible. Sometimes it smells like raw sewage. I don't think it's safe to get in there, etc. And we started to worry about, well, are cyanotoxins in the fish? Because even though they don't necessarily build up like methylmercury does, they still can be present. And so we applied for a grant through Cal EPA and asked environmental justice grant and received some funding to look to see if toxins were present in the Clear Lake fish and ultimately impacting the food web of the tribes. So that was in 2018 we received this funding. Next slide, please. So in order to just test the right fish, we met with Elam Indian Colony and some of the other tribes in the watershed who we knew were fishermen and relied on fish. And we checked in with all of the tribes. There's 7 federally recognized tribes in the county, in Lake County, and we also mentioned it at a regional meeting. So we asked tribal members in the tribal community which fish they were particularly concerned about in terms of looking at cyanotoxins, and created the list. And then we hired people to go fishing and bring in fish and shellfish, because the list had about 10 species on it. And there were people who and the Clear Lake hitch at that time was not in the early years were not yet listed. So we had some Clear Lake hitch from the lake, but we ended up getting, between the fishing that happened and also some fish that we already had preserved in our freezer here, we ended up with over 100 samples. And over the time, we because we had an inventory of fish that we knew where and when they were collected, what kind of fish they were, what size they were. We had done all of this measuring and documentation prior to freezing the fish in our freezer. So we've been doing that for a number of years. And so we were able to, with this grant from Cal EPA, pick and choose which fish we wanted to send off. And we wanted to have a temporal, spatial, and species variation of our samples. So, we had a number of years of fish that we submitted for analysis from all 4 seasons, because we wanted to see if cyanotoxins in fish in different parts of the lake and in different species had higher or lower levels of cyanotoxins, just because we had a wealth of fish to send off for analysis. So that's what we did. We sent off to Ben Genetics, which is a lab that we use for most of the analysis that we do for cyanotoxins, and they are in Sacramento, so it makes it pretty easy. All right, next slide, please. And this is what we found out. 59% of the tissue samples had microcystin toxin detects. Now, microcystin is a liver toxin, and it builds up, it's known to build up in the liver. So it was and we did do liver testing as well, but we wanted to also look at the tissue, because that's really what people eat with fish. So that was surprising to us to see that 59% of the tissue had microcystin toxin detects. Now, the next bullet, you see 20% of the species had average concentrations above the safe consumption of 1 meal a week. So OEHA, in their 6 cyanotoxin study that they did in 2012, they came up with this very useful table of action levels for exposure to cyanotoxins, or to microcystin and I think anatoxin. And yeah, microcystin and anatoxin. And they, for fish consumption, they had set a level of if you eat 1 fish meal a week, then the concentrations of microcystin in the fish should not be any more than 10 nanograms per gram. And so we've been asking them about, well, what if it's subsistence consumption, like 5 or more meals a week? What would that action level be? And they've never quite come up with those numbers, but it really is a simple calculation, at least as far as we're looking at it, that if it's 1 fish meal a week at and 10 nanograms per gram, then if it's 5 fish meals a week, that would be 2 nanograms per gram. So that's our math. That's girl math there. No, that's our math. And if we're wrong, OEHA, throwing out the challenge to please come up with that number for us, as we've been asking for years. Anyway, so we're also starting looking at it at, well, if you're doing 5 fish meals a week at that 2 nanograms per gram, 70% of the species had an average concentration above safe consumption. So I don't know if that was a question or yes.
Did you want me to advance to the next
Oh,
slide?
sorry. That is you could probably not hear the other words in my ear coming from another presentation. Okay, so so 70% of the species had these a cyanotoxin, a microcystin level that was above subsistence consumption safety levels. So yeah, you can see that the data can be found in CEDN because that's where we entered it. And you can also, if you go to Big Valley's website, bbrancheria.com/EPA, go to the Clear Lake Fish Cyanotoxin Study under the environmental data collection and see some more summaries of our project. Okay, next slide, please. And then we did this again in 2024. So we had some funding from that we've been putting together for various from various grants, and we have sent off 48 fish and shellfish samples from the lake, only caught during winter and spring this time. And these are just preliminary results. We're still QCing the information, but I just want to put it out there that what we have found. You can see that we're not talking about species in these bullets. We're talking about the samples. So that's what we're working on is sorting it by species. And it does look like I can tell you for sure though that the toxin levels that we're seeing is lower than what we saw in the earlier decade samples. So that's great. But more of them are above the 2% or the 2 nanograms per gram. So, but now we're just going to sort it into species and then be able to report on that more. I think that's my last slide, but let's look at the next one. Oh, so our next steps, we think it's really important to know what the contaminants are in the food web of the tribes. And, given the fact for aquatic species that there's an unknown, nobody necessarily knows like how much of a contaminant in the water it takes to accumulate into the animal or the plant. Like it's very complicated science, and I don't think it's like fully even developed with anyone, but we are looking for those correlations of the ambient water quality results with the toxin levels in fish. And so that's why we're continuing to do some analysis, because we are looking at toxin levels in the lake, and there's also data for mercury in the lake. So yeah, just looking at the food web and water quality data, and then the contaminants data in the foods, the aquatic foods of the tribe. And I think those are our next steps. And thank you.
Yeah, and I just wanted to, we were talking about the tribal beneficial uses process and past trainings and a couple of slides ago, and I think Sherry in past has mentioned the TBU Strategic Planning Caucus, but if you aren't aware of what that is, we're plugging it here. So it's a tribal-led group that meets to support intertribal engagement on tribal beneficial uses work throughout the state. The meetings are on the second Friday of the month in the mornings. And Sherry wanted me to share that the next meeting is October 14th. And folks from the water boards will be joining to ask questions and have conversations to really talk through how we can work together, we being the water boards and tribes, to move the TBU process along more swiftly than it has been. And if you aren't already involved with the TBU Strategic Planning Caucus, or you want to know more information, feel free to email Sherry, and her email's on this slide. Yeah, Mike.
Hi, Sarah. Hi, Anna. Thank you for your presentation, Sarah. And I want to compliment you again for all your work on Clear Lake with the tribes. I guess I just want to comment or make note of the meals per week. As you said, you try to think reflect more a traditional diet of 5 meals a week, and how I guess just it really jumped out at me the no significant difference between, if you try to restrict the population to a current regulated form of a meal or 2 meals a week that many tribes are, or the recommendations are due to health concerns, it may be considered safe. But if the tribes were to utilize a traditional diet more seasonally, probably would be 5 meals a week at least, that would 93% would be considered a dangerous level. So I think it's how you look at the numbers and are those appropriate statistics for the tribal community. So thanks again for your work.
Yeah.
Oh, go ahead.
Sorry, just tying that back into when we talk about the water quality objectives for TBUs, like that's exactly what we're thinking of, and why tribal expertise is so important in that process. But Sarah, please go ahead.
Yeah, I just wanted to say I totally agree with you, Mike, that it is when we start looking at it from that angle of, okay, this is the standard that might or might not being met for the general community, but is that appropriate for what tribes are actually, using and being exposed? And that's what TBU development is all about, is like looking at that. So I have to tell you, it was yesterday that I did the math to go, oh gosh, okay, if it's 1 meal a week is 10 nanograms per gram, then 5 meals a week, 2. And so let me look at all the data again. And it blew my mind. It did not occur. It did not, sorry to say, I've been sitting on the 2018 results and, and talking about it for a good long time, kind of waiting for, some help with that stuff. But oh my gosh, 70% of them were above the 2 nanograms per gram for safe consumption at subsistence level. That's a huge deal. That is a huge, huge deal. And I think we need to be looking at looking at things in that way in order to move them along more quickly. Like, it's not acceptable. And just to say, well, fish consumption guideline, don't do it. Well, just as you saw in one of my pictures, there are people here at Big Valley, and I know with tribes all over the state, who are eating traditionally and want to eat traditionally. And I know Sherry, that's the type of stuff that she works on over at SIA, but it's the reality of many tribes. And it's horrible that they might be taking their health into into like scary levels if they are just practicing their culture, or just doing cultural activities. That's just not okay. So
Thanks for that, Mike. Any other questions for Sarah? Okay, great. We're in the middle of our break time, but I feel like it was we got some good info there. So do folks feel good about coming back at 10:55, having like a 5 or 6 minute break, or should we have a longer break? Let's use our whatever you call them, emojis. And I am presenting, so I can't see the options. If you want a longer break, give me a thumbs up in your reactions. Otherwise, I'll pause and we'll come back at 10:55. Okay, see y'all at 10:55. Have a nice break. All right, folks, welcome back. We are going to dive right in, and I'm so excited to invite Lori Weber and Sammy Machida from the California Integrated Report team, who are going to walk us through different considerations and how they use tribal data in the integrated report process. This is something that we've talked about in past trainings, and so we wanted to make space to continue that discussion here. We're going to hold questions to the end so Lori and Sammy can get through all of the awesome content that they've put together. But as questions come up for you, feel free to add them to the chat, and I will kind of bring them up when we're at the Q&A phase. So with that, Lori, Sammy, take it away.
Great. Thank you, Anna. You can hear me okay?
Yep.
Okay, Great. Good morning, everyone. My name is Sammy Michishita. I'm an environmental scientist for the Assessment Policy and Process Unit in the Division of Water Quality at the State Water Resources Control Board. Presenting with me is Lori Weber, the Senior Environmental Scientist for the Assessment Tools and Support Unit. Our two units together developed the California Integrated Report at the State Water Board. And just as a side note, my supervisor and senior environmental scientist in my unit, Anna Maria Saenz, was unfortunately not able to make it today, but she is also a contact for any questions you have later on. So earlier we went through this wheel of water quality programs, and we will now be going over the integrated report in the assess section, which is indicated in the "We Are Here" marker at the top right of the wheel. States are required to submit the integrated report to the US EPA by April 1st of every even numbered year. The integrated report consists of two parts and is developed to meet the requirements of the Clean Water Act. The first component is the 303D list, which identifies waters that do not meet applicable water quality standards, indicating that beneficial uses are impaired or threatened. The 303D list is developed based on methods and requirements described in the Water Quality Control Policy for Developing California's Clean Water Act Section 303D list, also referred to as the listing policy. The 305B report is the second component, which informs the overall condition of surface water quality. The US EPA compiles the reports from all states into the National Water Quality Inventory Report that's submitted to Congress. Each integrated report updates the previous one. The current California integrated report is the 2020 and 2022 integrated report. Just a side note, these two were done together, which is why it's the 2020 and 2022. The 2024 integrated report was adopted by the State Water Board this February, and it was submitted to US EPA on time, and we're just still waiting for the letter of approval, which after will make it the most current report. So just in a couple weeks, hopefully. The Water Boards assesses the state's water quality on a rotating basin approach for each integrated report. We call these on-cycle regions, referring to the regional water quality control boards. The 2024 integrated report includes updates to waters assessed in the San Francisco Bay, Santa Ana, and Los Angeles regional water boards, and the Sacramento River watershed of the Central Valley regional water boards. Before I go to the next slide, I want to briefly acknowledge that the integrated report map here on the right indicates water bodies listed as impaired in dark green. And you might be wondering, the northwest portion of our state looks fully listed, but that's more so, it's slightly perceived inaccurately. It's that there's a little mapping reason for that. And so the watersheds in the North Coast are mapped so that the one river might be broken up into several segments. And so the map may seem to appear that there are more water bodies listed. And it's mostly that it just might be a couple segments of that full river. But later I'll show you how you can get to this current interactive map. So as mentioned, we do not assess the full state for every integrated report. New data from 3 on-cycle regional water boards are assessed to update the California Integrated Report, and new data from across the state is fully assessed once every 6 years. Data from the rest of the state may be reviewed for high priority off-cycle assessments. Maybe that's a specific pollutant assessment or a remapping of a water body segment. The Central Valley Regional Water Board is separated into 3 subregions and rotates an assessment each cycle. All readily available data and information from the surface waters are considered for the integrated report. Data on these surface waters are compared to the water quality standards in accordance to the listing policy to determine what beneficial use support. The timeline shows the approximate length of time it takes in each step to develop the integrated report. It takes about 4 years to develop one integrated report from the data solicitation period to submitting to the US EPA. So while it takes 4 years to develop one integrated report, we're required to submit the report to the US EPA every 2 years. So basically, depending on which phase we're at, we're working from either anywhere from 2 to 4 integrated reports at once. We are currently developing the 2026 integrated report and nearing the closing of the data solicitation period for the 2028 integrated report, which is indicated by the red triangles on those timelines. So next, I'll show you briefly how to navigate our web page and find several of our documents. Let me get to our web page. So if you get to our web page, you'll find the summary of the integrated report. There's a quick link here, as well as you can click on the map itself for the downloadable interactive GIS map that I mentioned earlier. On the right is our easy button to subscribe to our emailing list. Contact information here. Here's our general program email address, one for Lori and Anna Maria, and we have a data specialist as well. And if you keep scrolling down, you'll find links to some resources and helpful links for you. We have a fact sheet, and we're hopefully getting our FAQ up soon as well. And if you keep scrolling down, you'll get to this table where it shows the current and all the cycles that are in progress. Each one of these will take you to its own page with all the materials that you'll need that we post publicly. So if we go to the current integrated report, and this one will get updated to 2024 when it's approved by EPA. So you go to the current integrated report and you'll see the map again here that you can click. That'll take you to the GIS. You can also download the geodatabase here on the left. On the right, you'll find the approved 303D list. And if you're interested or want to look at a specific water body and all the details and information from the assessments, you can find it in the HTML version or the Excel version that we call water body fact sheets. We also assign condition categories 1 to 5 in water quality, where 1 is healthy and that the beneficial use are supported to every water body assessment. And you can navigate those by category number. You keep scrolling down and you'll find this big box with lots of links. These are all the public meeting, recording, presentation, and all of the documents that we make available. And so you can find a recording of the board meeting for the adoption, our presentation. You'll find the staff report of that cycle's integrated report, and you'll find lots and lots of appendices to go with that staff report. And the staff report mainly highlights the overview of the integrated report and pollutant assessments, methods, and maybe regional board specific topics that were covered in that cycle. And while there are a lot of appendices, the appendices do vary by cycle depending on any statewide or regional issues or topics that are identified and addressed during that cycle. The critical appendices to note are Appendix A, which is the recommended 303D list that the State Water Board approves or adopts, and then we submit to EPA for approval. We have the Appendix B I mentioned before in both the versions, and then Appendix C, which you can find here. And those three generally will never change in order, meaning A is always the list, B is always the water body fact sheets. And we do recognize that there is an overwhelming amount of documents, especially the appendices. And so we are working to improve and simplify these attachments each time as best we can and really reduce it so that there's not so many documents to look through and review. So going back to the slides here, I've highlighted some of the key items that are good starting points when you are looking through the integrated report. You can also find a list of adopted TMDLs from previous cycles, and then the previous integrated report list, 303D list as well. So it's the one always updates the other. So the integrated report is a non-regulatory report that identifies waters that do or do not support beneficial uses or attain water quality standards. As a separate action, the 303D list can be used to inform the prioritization efforts of the total maximum daily load, or TMDL, development or other regulatory programs of implementation to address impairments, to develop the development of permits such as informing monitoring requirements, or be used to prioritize grant funding such as non-point source management programs. Data and information from the 303D list also is used by other entities to inform water quality conditions, including the US EPA How's My Waterway Map application and the California Office of Environmental Health Hazard Assessments online mapping tool called CalEnviroScreen, which identifies California communities that are most affected by and most vulnerable to several sources of pollutant and their effects. So there's key steps to developing the integrated report. First is to assemble, meaning gather and organize all readily available data and information submitted by the data solicitation period cutoff date. Step 2 is to evaluate that assembled data to determine if they do meet the listing policy data quality requirements. Step 3 is to assess the data by comparing to water quality standards, which are the water quality objectives or numeric and narrative criteria that are protective of the beneficial uses. So for example, we assess the concentration of copper for the cold freshwater habitat beneficial use. Step 4, to identify impaired waters, meaning one or more pollutant exceeds those protective levels of water quality and the beneficial use is not supported. There are 4 options when we do the water body assessments. One is list, do not list, meaning the beneficial use is fully supported, delist, meaning remove from the previous 303D list, and do not delist, meaning that it's still exceeding water quality standards, so keep it on the list. Step 5 is the public process that is administered by the State Water Board, which includes board meetings, the staff report for public review, receive public comments, and more. And once the State Water Board adopts the integrated report, we submit the 303D list to the US EPA for their approval. Each integrated report cycle begins with the public notice for data solicitation. So the public notice identifies the upcoming cycle, the regional water boards that are on cycle, and then the cutoff date by which the data information should be submitted for consideration. And although the data and information can be submitted at any time, the cutoff date is essential to and established to allow timely data analysis and development of the integrated report. And if any data information are submitted after the cutoff date, they may be considered for the next relevant cycle. And detailed instructions on how to submit data to CDIN in our integrated report portal are available on the program webpage as indicated by our quick link that's on this slide. You can also get to that page when you're on our program page on the right panel under data solicitation. And our program email is always available for questions or assistance with data submission as well. And now I'm going to pass it to Lori Weber, who's going to go over the databases and data submission for integrated report. And Lori, you can just tell me when to move to the next slide.
Great, thank you, Sammy. I appreciate that. And yeah, I'll just let you know when I need the next slide. So hi, everybody. Sammy had already introduced me, Lori Weber. I work in the State Water Board for the Integrated Report Program. Moving on to the primary data sources for the integrated report, there are several data sources that we access to pull data to assess for the integrated report. Our main database is the California Environmental Data Exchange Network, or CDIN. CDIN is a repository of water quality monitoring data that is managed by the State Water Board by our friends in the Office of Information Management and Analysis at the State Water Board. CDIN contains data collected by water board programs such as SWAMP, Surface Water Ambient Monitoring Program, or other water board programs or monitoring projects such as special studies or TMDL monitoring. In addition, some permittees are required to submit their data to CDIN. So for example, the Irrigated Lands Regulatory Program coalition groups, they submit their data to CDIN. And community groups, the research organizations also upload their data to CDIN. The next sort of source of data for the integrated report is the integrated report upload portal. This is an online system, and it's basically an online survey that is managed by the integrated report program staff here at the State Water Board, mostly people in the tools and support unit, which is the unit that I oversee. And this is an option for submitting data that are not compatible with CDIN. So for example, continuous monitoring data or qualitative information such as photographs or narrative statements. In addition, and I'll talk about this a lot, that the IR upload portal is also where quality assurance project plans or QAPs are submitted. So that's something to keep in mind. We also download data, some data from the California Integrated Water Quality System, or CWIX database. CWIX contains data from permitted facilities such as wastewater treatment plants that discharge to surface waters. Dischargers are often required to collect data from receiving waters, which are the water bodies that they discharge to, such as a stream or a lake. For example, if it's a stream, they would be required to collect data both upstream and downstream of the discharge point to ensure that the discharge is not having an effect on water quality. That receiving water data is accessible for the integrated report if it meets all of our minimum data requirements. In addition, we download data from the US EPA Water Quality Portal, which is the public-facing version of the Water Quality Exchange, or WQX. The Water Quality Portal is also a repository of data collected by federal agencies such as USGS or US EPA. It also contains data collected by tribes. Many of you who have received EPA grant funding to conduct water quality monitoring have also submitted your data through the WQX. And then finally, we receive and assess data and information from other state and federal agencies, such as we look at fish advisories from the Office of Environmental Health Hazard Assessment. We also look at beach closure or beach notifications from the Federal Beach Watch database. Next slide, please. So just a quick note to clarify that about the connection between CDIN and WQX. CDIN and WQX are not currently connected. And we're actually familiar with the concerns about the lack of connection. We share those concerns with the data moving back and forth. And we're willing to work with anybody who's struggling with this and submitting data to both databases, or if you have questions about if your data are being considered for the integrated report or need help. What we do from our team's perspective is that we actually extract the data from each database. So we have part of our standard process is to extract the data. We review the data, convert both data sets into the format needed for our data quality checkers and our tools, compile the data for integrated report assessment purposes. One note, though, is that we do our best to identify duplicate data. But if you are submitting the same data to both data sets, we may miss that. And so we would ask that, at least for now, until there's a better connection, that if you're submitting the same data or even overlapping data, so if there's some of the data points overlap, to both CDIN and WQX for any reason, such as requirements from different funding sources, please notify us so that we can be on the lookout for the duplicate data. You can always reach out to us through our program email. It's here on the screen. I'll talk about it many times. It's the water quality assessment email inbox. And we have somebody monitoring that email every day, and we respond to questions that come in. In addition, if you have submitted data to WQX and you would like to know if we are considering it for the integrated report, feel free to drop us a line and ask us about the data set and where it is in the process. And just overall, we welcome your questions and feedback as it helps us to improve our process so that we can review and assess as much data as possible and really have a better picture of water quality in the state. Next slide, please. And so just real briefly to set the stage on data and information submission requirements for the integrated report. This is a very basic summary of the requirements and that for submissions for integrated report assessment. You can find much more detailed information in our policy document. Sammy mentioned the listing policy that goes through each one of these bullet points in a little bit more detail. And then also, as Sammy also mentioned, at the beginning of each cycle, we release a data solicitation notice with detailed information about how to submit data. So just high level, organization contact information is pretty important. Just to note, since developing each integrated report can take up to 4 years, there's always a possibility of a couple years delay between when the data were submitted and when the data are assessed. So keeping that contact information up to date in the database that you submit to is very important. And then if there's, this is also to ensure that if any questions come up from us regarding your data, that we have the correct contact information. Also, any numeric data should be in electronic format in a way that can be manipulated and compiled with other similar data in a spreadsheet form. We need the geographic coordinates of the location where the data were collected, because that helps us to link it to the water body for the assessment purposes. And quality assurance documentation, as I mentioned before, is very important. That can be an approved quality assurance project plan or QAP, or a QAP equivalent document. And just to note that our listing policy requires that data must be supported by a QAP or equivalent if we are to rely upon the data to identify a water body as impaired. However, data of any quality may be used as ancillary lines of evidence to make what's called a weight of evidence impairment decision. The weight of evidence decisions are done on a case-by-case basis. There's a kind of a much higher bar and a lot more scrutiny, but it is a possibility. And then for computer model outputs, we'll need, in order to assess the data, we need calibration information for the computer model and quality assurance documentation for the model. All this information is in much more detail in the data solicitation notice for each cycle. Next slide, please. Okay, I'm going to go into a little bit more specific details about the different databases that we download data from and what the requirements are for submitting data, at least requirements that we're looking at when we're downloading the data. So some of the guidelines requiring data submitted to WQX is that first, we only download data that is publicly available on the portal, so it must be marked final in order for us to access it. And then, as I mentioned before, a quality assurance project plan or equivalent documentation is required if we're relying on the data to make a listing decision or a decision that the water body is impaired for that pollutant. However, there are tribes that have already shared their QAPs, their US EPA approved QAPs with EPA. Do not need to directly share your QAPP document with the water boards. This is a sort of a new process that we developed while we have been reviewing QA documentation for data submitted for the 2026 integrated reports, which we are actually actively working on at the moment. We kind of reached out to EPA and we agreed on this new protocol where EPA will send us a list of the approved QAPs, and we indicate that those data sets are covered under a QAPP in our records. Although for other data sets that do not have a US EPA approved QAP, the documentation we still need the documentation to be submitted to us through the integrated report upload portal. So next I will go briefly over the data submission to CDN and the integrated report upload portal. Next slide, please. Okay. So this graphic is on our website. It's in our documents. It's just sort of shown here for reference purposes. It's summarizes the data types and information that can be submitted to CDN versus the integrated report upload portal. And sort of as a quick review, CDN is a database managed by the State Water Board's Office of Information Management and Analysis, which consists of water board data, including swamp data and other agencies. The IR upload portal is an online survey tool managed by Integrated Report Program, and it's a place to submit data and information that is not CDN compatible and QAPPs. So high-level summary, CDN compatible data includes chemistry data from water, sediment, and tissue, field data such as pH, temperature, etc., toxicity data, and bioassessment data. Data submitted to CDN must also have geographic coordinates of the location where the data were collected. There is a process in CDN for registering a station code and a station location. And we download those station codes as well when we download the data. QAPPs or QAP equivalent documents at this time cannot be accepted by CDN. QA documentation should be submitted to the integrated report upload portal to support your data for integrated report assessments purposes. Likewise, CDN cannot at this time accept continuous monitoring data or qualitative information such as photographs or narrative statements. These data should also be submitted through the integrated report upload portal. Next slide, please. And this is, just again, a high-level summary of the CDN data requirements. Again, there's much more information on the CDN website. There's also a dedicated email for the CDN help desk for information or help submitting data to CDN. Just overall, the green shapes in this graphic summarize the data types that can be submitted to CDN. I talked about that a couple slides ago. There are forms and templates available on the CDN website. CDN has a specific vocabulary for things like pollutant names that must be used and must be the same as when submitting the data to CDN in order for the data to be accepted into the database. In addition, when submitting data to CDN, you'll need to register a parent project and again, provide the geographic coordinates of the sampling stations. If your data types have a method detection limit and a reporting limit, these fields are required for integrated report assessments. I just want to make a quick note here that not all the fields required by the integrated report are required in CDN. So we're actually working with CDN staff on a better feedback mechanism so that it notify you when you submit your data to CDN, whether it's missing any critical elements that would make it unaccessible for the integrated report. This is still under development, not available at this time. So again, we recommend carefully checking the data solicitation notice for the integrated report, looking at those requirements and making sure that your data have those minimum requirements. And then at any time, this stuff gets complicated for us too. feel free to reach out with questions to the water quality assessment inbox, and then we can help walk you through the requirements and see, if your data is accessible. And then again, I'll keep saying this. CEDN does not accept QAPPs. I think there's a field for putting the name of a QAPP, but the actual document is not, it's not possible to upload a document to CEDN. So please submit your document through the IR upload portal. Okay, next slide, please. Thank you. Onto the IR upload portal requirements. This is where you can submit non-CEDN compatible data. As I said, continuous monitoring data, qualitative data such as photographs or narrative statements. Numeric data should be submitted in a format that can be manipulated, such as a spreadsheet, not as a PDF or a web link. What we would do would be to compile that data with other data of the same type for assessment purposes. Qualitative information such as photographs can be submitted as PDF or image files. And then QAP or QAP equivalent documentation may be submitted in PDF or Word format. Detailed instructions, again, are available on our website, and there's a direct link in this slide as well. Okay, next slide, please. All right, the big question. Here are some common reasons why data are not considered or do not pass QAQC for integrated report assessments. If the data are not ambient surface water quality, they're not considered accessible. So for example, groundwater, tap water, end of pipe tap water, air samples, obviously, end of pipe discharges, effluent data, or stormwater effluent. Those data types are not, or those sample types would not be considered ambient or accessible for the integrated report. Data may not pass quality screening. Each row of data is actually checked for quality using one of our screening tools, and it looks at important details such as the QC samples, and sorts the data into different categories based on how well they meet quality standards. Data missing critical information, such as reporting limits or method detection limits, if needed for that data type, those data are flagged as needing further review. In some cases, could be flagged as not passing quality. In addition, if we do not have a QAPP or equivalent documentation, the data may not be assessed. I did mention earlier that if data are not supported by QA documentation, they may be used on a case-by-case basis for a weight of evidence impairment decision. This can be either to list or to delist a water body as impaired on the 303D list. However, these types of decisions are pretty complex. They go through many levels of review, and we strongly recommend backing up your data with the appropriate QA documentation. It makes our assessment process much more straightforward. In some cases, another reason would be inaccurate or missing spatial information. So if we cannot associate the data, if the sampling coordinates are incorrect, if the station maps somewhere outside of California, another country, sometimes we've had that, or even if it's too far away from a water body for us to associate it with confidence with the water body segment, we may not be able to assess the data. And then, of course, if the data are quality control measures, such as blanks or spikes, the data are not assessed. They are not ambient samples. And our screening tools do a pretty good job of catching these data. Not a concern on our end. And then finally, I kind of mentioned this before, sometimes we'll find errors that we think are fixable, but we need a contact person. If we're unable to contact the data provider to make corrections, we may not be able to assess the data. So this is why it's pretty important to maintain up-to-date contact information, whether you submit data to CDIN or WQX or through the IR upload portal. Okay, next slide, please. Again, a summary of the data types that are considered for the integrated report. I mentioned three matrices: water, sediment, and tissue. For the integrated report, we assess data from water. The water data is downloaded from all of our sources, from CDIN, from IR Upload Portal, CWIX, and WQX. Data from sediment and tissue. Currently, our tools only receive or only download those data from CDIN and the IR Upload Portal. We are actually working on a tool to download and format sediment and tissue data from WQX so that we can assess the data for the integrated report. Again, I want to point out, since this is a training on tissue data, and I have heard that it sounds like there is some tissue data collection going on. And the data may be, I'm not sure if you're submitting the data to CDIN or to WQX, but if you're submitting tissue data or sediment data to WQX and you would like it assessed for the integrated report, please contact us so that we'll have that on our radar. We can either prioritize the tool or work with you to ensure that the data are submitted in a way that we can assess for the integrated report. Okay. Next slide, please. Thank you. Okay. Sorry, I had too many windows open here. All right, water body fact sheets. So sort of shifting gears a little bit, Sammy talked about our public-facing documents and how we present or make available the results of our studies. This slide introduces some of the key terms related to the integrated report and illustrates how water body fact sheets are organized. The water body fact sheets contain the details of each assessment. So they're pretty, there's a lot of information in the water body fact sheets. And when reading the water body fact sheets, keep in mind that there are three key levels of detail: the water body itself, the decisions, which are made at the pollutant level, and the lines of evidence, or LOEs. And so these three levels of detail are shown or illustrated in the right-hand side of the graphic. And I'll just sort of briefly walk you through each one. So this very top box here, a water body. As you would expect, it's a portion or a segment of a water body, such as a lake or a stream segment or a coastal beach, that has been mapped for integrated report purposes. Each integrated report water body is mapped as a GIS feature, hence our interactive map, and assigned, each segment is assigned a unique name and a unique ID in our database. The next level of detail is the decision. Decisions are written at the pollutant level, and there may be more than one decision in a water body. It's helpful to remember here that the 303D listings are reported at the decision level. And then finally, the next level, more finer level of detail is the line of evidence. And LOE is even more specific. The LOEs are the building blocks of the decision. So they include details such as the beneficial use that was assessed, the objective or the numeric threshold that was used to assess the use, that was applied to assess the use, the matrix that the data came from, such as water, sediment, or tissue, the monitoring project, the group that collected the data. So each decision, these are all organized, all this information is organized into individual lines of evidence. And then those lines of evidence are rolled up into a decision by pollutant. So each decision may contain from 1 to up to, and in some cases, hundreds of lines of evidence, depending on how much data was collected in the water body. And then on the left-hand side of the graphic, this sort of illustrates how these pieces of information are organized into the water body fact sheet. First, the lines of evidence for the same pollutant are organized into a decision. A water body may contain more than one decision, depending on the type of data collected from it. Each pollutant gets its own decision. So for example, if you have a water body where both mercury and indicator bacteria data are collected, we'd end up with two decisions, one for mercury and one for indicator bacteria. If the data show impairment, the water body may be listed for both pollutants. That is, there would be two 303D listings in the same water body. Next slide, please. So as Sammy mentioned earlier in the presentation, after the data have been assessed and compiled into the integrated report, we begin the public process. The integrated report contains many different documents, which we saw in the on the website, which includes a staff report and the draft 303D list of impaired water bodies. Once this information has been compiled into the documents, we release this to the public for a 45-day minimum public comment and review period. However, starting with the 2026 integrated report, we're working to extend the review period to a 60-day public review period. During the public review and comment period, we will host staff workshops, meet and speak with interested parties, and the State Water Board holds a hearing to receive oral comments on the draft report. And again, we're happy to meet with people at any phase of the integrated report development process, but this step in the process is where most of our engagement public engagement occurs. After the close of the public comment period, we develop a response to comments, a written response to comments. In some cases, we may revise the listing recommendations based on the comments received. And we would revise the staff report as appropriate before compiling into a new proposed final version of the documents and taking this to the State Water Board to consider adoption. The State Water Board administers the public process for the integrated report. However, we do work very closely with the regional boards to assess the data, develop the integrated report, write the documents, respond to comments throughout the whole process. Next slide, please. And then once the State Board adopts the integrated report, we then submit to US EPA. They're due to the EPA no later than April 1st of every even numbered year. Prepping for submittal to EPA consists of translating the data and information to the federal online system called the Assessment Total Maximum Daily Load Tracking and Implementation System, or ATTAINS. That's the EPA, the federal database. Once we've submitted the report to EPA via ATTAINS, EPA has 30 days to review and approve the 303D portion of the integrated report. And during this time, EPA can challenge any assessments we've included in our list. If the EPA doesn't agree with an assessment, this could result in what we call an overlisting, meaning that the EPA can determine a water body should be listed as impaired when we didn't propose it for listing, or they can issue a partial approval and make changes to our assessments as appropriate. And this could happen if the EPA thinks that we didn't assess all readily available data, or if they think we should have used different objectives, guidelines, or assessment strategies. And then after the EPA approves the integrated report, that report becomes the most current report. I think Sammy mentioned earlier We are waiting for the EPA to approve the 2024 integrated report, and that will become our current integrated report. Okay, next slide, please. Okay, a little bit about tribal data considerations for the integrated report. We have historically not been very consistent or had a consistent statewide approach for how we evaluate data collected by tribes. We're working to make that better, and we're working to better identify tribal data and to assess the data appropriately and communicate the results of our assessment. Prior cycles, the regional boards had worked more closely with the tribes, starting with the 2026 integrated report. We're implementing a more statewide approach, a more statewide and consistent approach to identifying and evaluating data collected by tribes. There are two main components of what we are planning to do for the 2026 cycle. First is that data collected within the boundaries of federally recognized tribal land by any entity will not be assessed for the integrated report. And the reason that we're doing this is that EPA's responsibility for the 303D list, it's the EPA's responsibility for 303D lists. So they will not review or approve any proposed listing or any proposed impairment decisions for data collected within within the boundaries of federally recognized tribal lands. And state and regional water quality standards do not apply to waters within these boundaries. So what we're doing for the 2026 cycle is that we're reaching out to the tribes that have submitted data either through CDN or WQX that we are evaluating for the 2026 cycle, and offering tribal consultations and opportunities to discuss. Additionally, the US EPA has stated that a tribe that doesn't have their own 303D programs can reach out to us, to them, to discuss impairment assessments for their tribal waters. So that's step one, is to summarize all of that. Data collected within the boundaries of federally recognized tribal lands is sort of excluded from assessment for the integrated report. But we are reaching out, and we are offering consultations because this is a new process for us. Next slide, please. Okay, and so then the second step, or the second kind of component of this approach, is that data collected by tribes, submitted or collected in areas that are bordering federally recognized tribal lands or outside of federally recognized tribal lands, those data are considered readily available and can be assessed for the integrated report. That's our justification, is that if it's collected outside of tribal boundaries, it's readily available. And if the data meet the requirements of the listing policy, we would evaluate the data for integrated report assessment. We're not sure if this is a surprise or not. This is why we wanted to come to this presentation and reach out, and we are offering tribal consultations individually. But we want to make sure that we're doing it right. And so we're working to improve our engagement, to increase awareness of the program and transparency of how the data are used. Again, offering tribal consultations. We've identified the data that we've downloaded that has been collected by tribes for the 2026 cycle, and will be reaching out to each one of the data providers with individual letters, asking sort of summarizing the results of our proposed assessments and asking for feedback and communication. And then moving forward, we will be doing these consultations each time we are on cycle. We'll do a better job of identifying data collected by tribes and reaching out to people. Probably our goal will be to do it earlier in the cycle. Okay, next slide, please.
Awesome. I thank you so much. This is another like super in the weeds, detail rich. I'm probably going to watch this recording like 4 more times before everything sinks in. But we wanted to get a pulse check of the folks that are joining us live to see how like tell us more about your data. And so I'm going to launch a poll, and it has the 3 questions listed on the slide. The first is just considering what type of water data do you collect? Water, sediment, tissue. You can select more than one. You can select all that apply for any of these questions. The second question is, where do you submit your data if you submit it anywhere? We talked a lot about CDIN and the integrated report upload portal, but a lot of our conversations in this space and others that I've had with just tribes being in other conversation is really focused on WQX. So we anticipate that not a ton of folks submit to both places, for example, and you're just submitting to WQX, which is great. And then curious about why you share your data. If it's a funding requirement, you're just an open data type of group and tribe where you just want to get your data out there so it can be used, or maybe you don't share your data, and that's also great. And we are a small but mighty crew today. I think there's actually an attains training happening at the same time. This is why Sarah had to jump off, so that we might be competing with US EPA on our on our attendees today. Okay, but I see most folks have submitted. So I'm just going to end the poll and share the results. These don't show up in the recording, so I just want to walk through. 100% of the people that completed the poll said they collect water data. So not a ton of tissue collection or sediment collection at this point, which is great. Maybe after these trainings, you'll be able or want to submit tissue, or, long live water data collection, all good things. The second, as we suspected, folks are really only submitting their data to WQX. So the folks joining us in this call today, all that, the flags that we kind of brought up about duplicate information, you got to worry about that because you're just submitting to WQX, which is great. And then, why do you share your data? Most folks, it's a funding requirement. So if you're submitting to WQX, US EPA requires when you receive funding that you submit the data to them. And a couple of folks just want the data to be used, which is also great. We appreciate that. Oh, and I never pressed the share result button. Sorry, folks. So I'll leave that up for a second so you can scroll through and see the results for yourselves. But this is great. This is, I think, close to what we were expecting to see. I don't know, Sammy or Lori, if you have any thoughts while folks are reviewing the results before going to the next slide.
Well, I think it's helpful to know, at least that for a group of people that are participating in this meeting, that it's mostly water data. Again, I would encourage people, if you're collecting tissue or sediment data, submitting to WQX and you'd like it assessed for the integrated report, to reach out to us. We have a lot of plans to improve our processes, and if this is something that is a high priority request, we'll see if we can move it up in the priority list. And I just also wanted to flag too, y'all probably know this, but for the people not in the room with us today, when you submit your data to WQX, you have the opportunity to mark it as final. So you can tell USCPA, we're submitting this to you because of funding requirements, but we don't want anyone else to see it. So you wouldn't mark it as final. We can't see that data, which is great because you didn't want us to. We can only see the data that you submit to WQX and mark as final, which makes it public. And so that's just another thing to keep in mind. If you're submitting to WQX and we're not receiving the data, or you're not seeing it show up in like the listing details, it might be that you've submitted it to WQX, but just haven't marked it as final. And that can be something that you change moving forward. Okay. I'm going to stop rambling and we can move on to the next slide.
Thanks so much, Anna, for doing the poll. We just have a couple more slides to close off. What we've gathered here are the number of projects with tribal data that we reviewed and evaluated for the 2026 integrated report. So this table shows the number of tribal projects with data collected on or outside the boundaries of the federally recognized tribal land per each on-cycle regional water board for the 2026 integrated report. And some projects do have data for both categories. So disclaimer is that, lines of data vary and that some projects may include data that are not ultimately that were not ultimately assessed for the integrated report for 2026. And of course, our process is imperfect and we are working to correct where there are errors still, such as geolocations not confirmed for some. And we're developing and continuing to refine the process. And one of the desired outcomes we have from the tribal engagement discussions is to refine those records too. So our data assessments and our reportings get better and better each time. So we like to end by highlighting some upcoming events and timelines for the concurrent cycles that are in progress. For 2026 integrated report in July, we sent out an introductory message on about the integrated report and the phases that we're in for the different cycles through the Office of Public Participation in Tribal Matters emailing list, and then the tribal contact list that the Water Boards maintains. If you didn't receive the email subscription message or the direct email, please let us know. We're always working to update the contacts list, and there's a chance our attempt went to perhaps an outdated email or just got lost in spam. The public comment period starts when the draft staff report is released, and that's another opportunity where you can provide your input for 2026 integrated report. That'll be the start of next year. And the notices and stuff will all go out in the email list, subscription list. For 2028, the data solicitation is happening now, and it closes noon of October 23rd this year. And then following the data solicitation cutoff date, if you recall from earlier, the first step is data assembly, and which actually takes quite a few months. And once we have identified tribes that we would like to reach out to with data that's related to the 2028 cycle, we'll start sending out letters and offer consultation. And that's likely going to happen sometime in 2025 because it'll definitely be after we do the data assembly. And then, of course, we'll do the public review comment period for 2028's draft staff report. That'll happen sometime spring 2027. So you'll get a lot of the notices for these upcoming dates if you also subscribe to our programs email list, which was that quick link at the top right of our webpage that I showed earlier. And also the general timeline of key steps are available on the table that I showed on our program page. And those pages get updated each time we have confirmed dates and releases of documents as well. So just to end off, these are some key links that we've mentioned and hopefully can help you guide your way through data submission and data for integrated report, anything integrated report. Here's a little image of our fact sheet that you can also find here linked or also in our webpage. And that's it. I'll pass it back to Anna.
Yeah, I selfishly added a question early in the chat, but for the sake of time, just wanting to flag, Sammy mentioned the condition categories, and with all the love in my heart, every time you talk about those, I like don't remember which one is what. So they put together a slide that breaks down what each of the categories mean, and that'll be included in the slide deck that'll be posted. So just flagging that for folks. We went through, thanks, Sammy. We went through a lot of information. Are there any questions coming up for folks at this time? I suspect a lot of like digestion is happening, information digestion. If anything comes up, we've got the emails smattered for the slide deck, so you can reach out to any or all of us or just me, and I can forward to the appropriate person. But for the sake of time, I want us to end on time so y'all can enjoy your lunch. I just wanted to flag, if you could go to the next slide. We haven't scheduled the specific dates for the trainings for later this year on data analysis and interpretation and OEHA fish consumption advisories. There's an availability poll that's open. It's similar to the one that I think most folks that are on the call now completed earlier in the year to schedule these trainings. We're keeping that open through October 15th, and I'll send an email with links, but we want to make sure we schedule the next 2 trainings during a time that you can attend. So if you've got a couple minutes, please take the poll to let us know, and we'll get those scheduled. Like, I'm going to try and send an announcement on October 16th so people can start registering. Also wanted to flag that these slides and this recording are going to be posted by the end of this week. So I'll get those up and then send another email announcement directly to people that registered and also through our Safety work group and Tribal Matters email lists. And I think that's it for now. So if you go to the next slide, if any questions come up, you can't remember who presented what, and you just have a question about QAPS or integrated report or whatever, feel free to reach out to me directly. And then Sherry's contact information is there for the TBU Strategic Caucus. Thanks, y'all. We were a small but mighty group today, but hopefully it was helpful for you. And again, please share the slides and the recording with your colleagues and partners as soon as they're available. And I will also, at the end, if you go to the next slide, Sammy, we've been sharing links and things in the chat throughout the training. Tessa added a response to a question that we had in the chat. So I'm going to add all of that into the slides, and those will be available as well for future reference and ease of reference, because we're all going to lose the chat as soon as we hang up today. All right. So with that, thanks y'all so much for taking the time to really get in the details of quality assurance and integrated report today. And we'll see you next time. Bye, everyone.
Hi, thank you.